Hi, welcome back to the fifth part of motion. Okay, so in the last class we were discussing about the graphs, right? And we discussed about the velocity time graph, where I told you that every information that you need to gather, you will get it from the velocity time graph. So in the last graph, in the last class, if you take a look, this was the last class that we discussed, right? So if you take a close look here, we found out the area under the velocity time graph, right? This was the area. This was the last question that we did. So the answer was 160 plus 80, that is 240 meter. So this was the area covered, right? And the area covered under the velocity time graph gave you the displacement, right? So this was the first thing that we discussed, that we will get two things from the velocity time graph. One is the area covered under velocity time graph will give you displacement, right? And also the slope of the velocity time graph will give you acceleration, right? So now coming to the fifth part, in the last class we discussed that area covered under velocity time graph will give you displacement, okay? In today's lecture we'll discuss about the area, the slope of the velocity time graph. So what exactly do we get from the slope of the velocity time graph? We get acceleration, right? I told you already here, if you take a close look, this is theta, then this is basically change in velocity, right? So acceleration is anyways change in velocity, v final minus v initial upon t final minus t initial, yes or no? And here also, if you use this relation tan theta, which I already told you in the last class, tan theta is equal to perpendicular by base. So on the base you are getting change in time, this is delta t. On the perpendicular you are getting delta v. So tan theta is basically delta v by delta t, right? So delta v by delta t is basically what? The change in velocity upon change in time, okay? So anyways it will give you the acceleration. Again I told you in the last classes, in the last lectures, that if the theta is constant, right? If theta is constant, then what exactly you will get? You will get the, see, this is the linear graph, right? And here theta is constant, that means acceleration, because theta is constant and hence slope is constant, therefore acceleration is also constant. If theta is varying with time, then obviously the acceleration will change. If it is increasing angle, then acceleration will increase. If it is decreasing angle, then acceleration will be negative, right? We already know about the acceleration. There are two types of acceleration. One is the positive acceleration and other is the negative acceleration. So let's go through this graph once. Slope of velocity time graph is the acceleration. So here we have taken 2 points, right? Here we have taken 2 points. One is 10,16 and other is 20,32, right? In 10,16 and 20,32, this is basically x1 y1, this is eventually x2 y2, then slope obviously y2 minus y1 upon x2 minus x1, 32 minus 16, right? This is y2. So y2 minus y1, 32 minus 16 upon 20 minus 10, 20 minus 10, right? So x2 minus x1 is 20 minus 10. If you solve this, you are getting the acceleration 1.6 meter per second. Now, because this acceleration is constant, you find it between any 2 points, anywhere you will get 1.6 meter per second square, okay? So you need not to worry, because anyways slope is constant here. Therefore acceleration is constant, right? How do we check slope is constant or it is varying? By checking the angle. Here angle for every point is same, theta. For this point also theta. For any other point, same angle theta, right? So if the angles are same, then we can simply say that slope is constant, and if a slope is constant, that means the acceleration is constant. Okay. Now, how to be sure whether we have to find slope or area? So suppose you have three types of graphs here. One is distance time graph, one is velocity time graph, and one is acceleration time graph, right? So in distance time graph, if you find the slope of the distance time graph, you will get velocity. If you find out the slope of the distance time graph, it will give you velocity. Okay. If you find out the slope of the velocity time graph, then you will get acceleration. So this is normal. Slope of distance time graph or displacement time graph will give you velocity. Slope of velocity time graph will give you acceleration, right? So it can also be set as displacement time graph. So now this is even better to say that displacement time graph, slope of displacement time graph will give you velocity, and slope of velocity time graph will give you acceleration. Area covered under acceleration time graph. Like in 9th class, usually we don't discuss for the acceleration time graph. When you will go in class 11th, there we discuss more often about the acceleration time graph or conversion of displacement time graph to velocity time graph and velocity time graph to acceleration time graph. But in class 9th, we have a very limited kind of syllabus. So if like this is the extra edge I am giving you guys, because acceleration time graph is not, ultimately it's not in the syllabus, like you can get the extra knowledge from here. So that is why I'm not giving like too much time to it or too much explanation to it, because eventually it will help you in class 11th only, and then we'll discuss that part. So you just need to focus on two types of graph. One is the distance or the displacement time graph, and the next is the velocity time graph. I mean, if you are in class 9th, your main focus, your main goal should be in discussing about the velocity time graph. Okay. So anyways, but we can still get some extra edge, right? So suppose you are provided with the acceleration time graph. Like if I say that we have the acceleration time graph, then if you find out the area covered acceleration time graph, it will give you velocity. Okay. And then if you find out the area covered under velocity time graph, it will give you distance or displacement. Okay. So you can learn this thing. This is very easy. Like if I want to find out velocity, with the help of distance time graph or displacement time graph, we can find out the slope, and by the slope we can get the velocity. Slope of velocity time graph will give you acceleration. Area covered under acceleration will give you velocity, or basically area covered under acceleration time graph will give you change in velocity. Okay. There is a big difference between velocity and change in velocity. So you can write down that area covered under acceleration time graph will give you change in velocity, because anyways, let me tell you, like suppose acceleration is what? Delta V by delta t, no? So delta V is basically acceleration into delta t, right? So even by the maths here, you can clearly see that if you are, like suppose if I draw this, if I take a simple example of acceleration time graph, just take a close look. On the y-axis, I have taken acceleration. On the x-axis, I have taken time. Now think, suppose this is a constant acceleration. So anyways, acceleration is constant here. Now area covered under this acceleration time graph. Okay, so this is say, like let me find from here to here. This is say T1, this is T2. So area covered under acceleration time graph. Area covered under acceleration time graph. See, acceleration is constant here, right? So here you are getting, here the value is A. Yes or no? Here this length obviously is T2 minus T1, that is delta T. Yes or no? So eventually it is not exactly very wrong to say that you will get velocity, but it is suggested that it is more better to write change in velocity, because eventually A is delta V by delta t. It is not V by t. It is change in velocity upon change in time, or rate of change of velocity. Like, you know, in physics, the definition for anybody remains same. Like, it cannot happen that for me, acceleration is defined as velocity upon time. For some other person, acceleration is defined as change in velocity upon time. No. If the definition says that acceleration is defined as the rate of change of velocity, that means this is the clear mathematics to write it, right? A is equal to delta V by delta t. You cannot write V by t. No. Eventually, if initial velocity is taken 0 and initial time is taken 0, then we can write V by t. Then it's completely fine. Then we are, you know, making it simpler for our own use. But by definition, acceleration is defined as rate of change of velocity. So always remember, area covered under acceleration time graph will give you change in velocity, not velocity. Okay, because it will be, and that change will be occurring between two times, or we can say for a particular time interval. So that change can happen, like, you know, there can be a different change at different time interval. So delta V, so remember in class 9th, nobody is gonna ask you, but this can be taken as like, you know, we have in junior classes, we usually have HOTS question, you know, higher order thinking skills. And sometimes we are getting into competitive exams, like we are giving some, you know, Olympiad level exams. So there they can ask there. Okay, so remember, area covered under acceleration time graph will give you change in velocity, not velocity. Remember this. Okay, then area covered under velocity time graph will give you displacement, right? Even though it is change in displacement again, because again velocity is delta S by delta t. It is not S by t, it is delta S by delta t. Change in displacement upon change in time, right? So in both the graphs, area covered under acceleration time graph will give you change in velocity, and area covered under velocity time graph will give you displacement or change in displacement. Are we clear with this? Okay, so this is what you guys need to learn, and the most important is the velocity time graph. Okay, coming to the next part. Now, we have the equations of motion. I really love this part. You know, in class 9th, this is the only part where we have like too many numericals, too many questions, you know, mathematical part, because without the mathematics, physics is very incomplete. You know, it's like a heart to a body. Maths is like heart to the physics, or backbone, we can say, you know. So anyways, we're going to discuss about the equations of motion. I really love this topic. So in this chapter, or in this class, we're going to discuss 3 equations of motion. Okay, so there are 3 equations of motion. We'll derive these equations by 2 methods. One is the graphical method and other is the mathematical method. Okay, and I personally call it as algebraic method of equation of motion, because in class 11th we also derive it using the calculus method. So one is the graphical method, which I will be discussing it today. Also, I'll be discussing about the algebraic method, that how these 3 equations of motion are derived. And once you get the derivation, no, then you get the exact interest that, okay, you can directly learn the equations of motion. You can directly apply the equations of motion in the question, but once you derive it, you will feel, you know, the core of physics, that, okay, now we are understanding bit of a physics. Okay, so I told you already, there are 3 equations of motion. One is V is equal to U plus AT. This relation exactly, see, in every equation there is some or the other physical quantity missing. Like in the first equation of motion, if you take a close look, here displacement is missing. Here displacement is missing. In the next part, if you take a close look, we don't have the final velocity here. And in the third part, I mean the third equation of motion, we don't have time. So these 3 equations are simply used to derive one or the unknown variable out of these, velocity, acceleration, time, displacement. So these, I told you already that these are the 5 parameters on which we decide the motion of an object, right? We define with the help of these parameters that what kind of motion it is, we get the exact knowledge of motion of the object or the particle with these parameters only. So these parameters are very important, right? So first equation of motion is v is equal to u plus at, where v is the final velocity. We have it here. V is the final velocity. U is the initial velocity, A is the acceleration, and T is the time. So you need to learn this. V is equal to u plus at. Now this gives you the exact relation between velocity and time. That is why we call it as velocity time relation. Okay. So first equation is also known as velocity time relation. Velocity time relation. Okay. So v is equal to u plus at, first equation of motion. Then second equation of motion is s is equal to ut plus half at square. S is equal to ut plus half at square. Now this gives you the exact information about the displacement and time. Okay, so that is why we call it as displacement time relation. So first one was velocity time relation. Second one is displacement time relation. Okay, because it relates displacement with time, so simply displacement time relation. Got my point? But eventually, as you said that no one is studying. See, whenever you start something, so what happens that you face many problems, many hurdles, but you have to remember that, you have to keep going with discipline, with motivation, with positive thoughts. So anyways, I am doing my work which I love. There will be a time when people, when students, and I know what exactly I have been giving on this. So it's all my effort that I am putting, and eventually the hard work pays off. So I don't mind right now that if anyone or very few people are taking this lecture seriously, but eventually I know that we'll set the benchmark. Buddy education teachers are personally very qualified and very experienced, and they are putting so much effort in this. So yes, the time will come when we will be on the top. So let's wait for that. Till then, let's keep going. Yeah. Yes, definitely. We'll be keep going. Don't worry. We'll never stop. Right. So v square is equal to last equation. Here you don't have the time. In the last equation, we don't have the time. So what exactly is this relation telling? Velocity displacement. This is the relation between velocity and displacement, right? So this relation is known as velocity displacement relation or displacement velocity relation. See, I will explain this equation of motion using two methods. Displacement velocity relation. Okay, so these are basically the three equations of motion, and I am sure that this will have certain numericals. But before that, equations of motion by graphical method, as I told you that derivation is very, very important to understand physics. See, right now you are in class 9th, okay? We have limited syllabus, but in next class, in class 10th, there will be certain relations. So change your pattern of studying. Once you change the pattern, physics becomes very easy. Now exactly I tell you what exactly the pattern should be. Always, whenever you are studying, whenever you are getting some relations, always go for the derivations, right? Because in class 11th and 12th, for every relation there is a derivation. Okay, so remember that the derivation will help you to understand physics better. So from now on only, if you are interested in physics and you want to learn it the easy way, so remember that whatever equations you are solving, either it is equations of motion, or later you will get the second chapter is force and laws of motion, and then gravitation, and then the fourth chapter with the fluid part, Archimedes principle and all. So once with every chapter you will get to know the new relations. You can only know, but if you derive it, you will get the exact knowledge that okay, this is the physics, this is the science behind it. So from this only start deriving the equations. Okay, this is my personal suggestion, and I strongly recommend everybody to practice these equations of motion. So there are two methods in class 9. Basically there are two methods. One is the graphical method and other is the algebraic method, right? So first let's go through the algebraic, the graphical method, and then the algebraic method. So we have a bus which is moving along a straight line, okay, with uniform acceleration. So at time t 0, initial velocity is u, okay, and then after some time the final velocity is v. So what do we exactly have? We have the final velocity, we have initial velocity, we have time, we have acceleration, okay. So and also there is one more thing, that particle or the object is traveling on the same or on the straight road, you can say. So straight path, once you have the straight path, that means the displacement and distance are equal here. Okay, this is also one very important aspect. So now s be the displacement here. So v is the final velocity, u is the initial velocity, t is time, acceleration is a, and displacement also s. So let us draw a graph here, right? So let us draw the velocity time graph for the bus traveling on a straight path. On the y-axis we have the velocity, on the x-axis we have the time, right? So at time t is equal to 0, at time t is equal to 0, the velocity was u, okay. Eventually bus was not at rest, it was already moving, okay. And after some time we got the velocity v, and that is time t, okay. So this is the acceleration now. Slope of velocity time graph is the acceleration, right? This is a, b, c, d. We have taken a rectangle a, b, c, d, okay. So till here it is u, right? And this whole complete is v. So change in velocity from a to b is v minus u. See, check. From O to D, okay, this is the origin. From O to D, the velocity is u, right? But from O to C, the velocity is v, okay? So if I write it for just AB, this complete is v, this complete is u, so this much part is v minus u. Got my point? This AB, distance between A and B is v minus u, and this becomes t, because this is 0 and this is t, so this becomes t. Now let us take this triangle, right? This is what? Theta. Again use tan theta is equal to perpendicular by base. Yes or no? Perpendicular is v minus u, base is t minus 0. So tan theta is basically v minus u upon t minus 0. Got my point? Okay. So tan theta comes out to be v minus u by t, but v minus u by t is also the acceleration. So here acceleration comes out to be v minus u by t, because slope, this is the slope, right? and slope of velocity time graph will give you what? Acceleration. Slope of velocity time graph will give you what? Acceleration. So now from this we got a is equal to v minus u by t. Bring t here with a, so this becomes at is equal to v minus u, or v is equal to u plus at. Are we clear with this? V is equal to u plus at. So this is how we got the first equation of motion using graphical method. This was all graphical. You know, we draw the graph and then we were able to find out the relation. So v minus u by t is equal to a, or v is equal to u plus at, right? So this is it. Now we got the first equation of motion, v is equal to u plus at. Let us come to the next part, the second equation of motion, right? So I hope this topic is clear, right? So v minus u upon t is equal to a, or v is equal to u plus at. Coming to the next part, see, now I told you the slope of velocity time graph will give you acceleration, but area covered under velocity time graph will give you what? Displacement. So if you take a close look, we have the second equation of motion, s is equal to ut plus half at squared. This is the second equation of motion, right? Second equation of motion. So if this is the second equation of motion, so anyways we need something that should relate displacement with acceleration and time. That should relate acceleration, displacement and time. Hello beta. So let us find out the area covered under velocity time graph. See, I told you already that area covered under velocity time graph will give you displacement. Area covered under VT graph will give you what? Displacement. Right, will give displacement. Okay. So this area comprises two parts. So either you can break this graph into two parts. For second equation of motion, you have to take down this area in two parts. So this becomes the area of rectangle, right? So what you can do here is, and this is important because you know, if you take the area of trapezium, then you won't be able to find out the second equation of motion. But if you take this graph into and break this down into two parts, like you just have to add, what you have to do is you have to take the area of rectangle plus area of triangle. Okay, so let's add this down. Area of rectangle plus area of triangle will give you the total displacement. Okay, so area of rectangle plus area of triangle will give you the total displacement. Area of rectangle plus area of triangle will give you the total displacement. So what exactly is the total displacement? So take a look. This is it. So right, let's take this out. This area is UT. Okay, so UT is the area covered under the rectangle part. Now for the area of rectangle, this is area of rectangle plus area of triangle, right? So now for triangle, just check. This length is v minus u by t. I mean, this is the height of the triangle. Base is time, right? So what is the area of a triangle? Half base into height, right? So area of triangle is half, base is time, into height is v minus u. Height is v minus u. Take a look. Okay. So this is how we got the first equation. Now, this is the area I was talking about. So you just need to add both the areas, area of a rectangle plus area of a triangle. See, area of a rectangle plus area of a triangle. So area of rectangle is length into breadth, you got UT, right? Half base into height. So this is base T, this is height, right? Okay, this we have already done. So in the place of, see, just take a look, OE. What is OE here? It is time, right? In the place of AE, AE is the initial velocity, right? So in the place of OE, it is time. In the place of AE, it is initial velocity. So area of rectangle, you got UT plus again base is time, T, and AB is AT, because you know here we can write down na V minus U. This is V minus U, and V minus U is E, because V minus U by T is A, right? So V minus U can also be written like AT. Got my point? If we use this as first equation of motion, so V minus U is equal to AT. So in the place of V minus U, here we are writing AT, because we got the relation from the first equation of motion. V minus U by T is equal to A, or V is equal to U plus AT. So V minus U can also be written as AT. Okay, got it? Now just multiply these two, AT with T, so it will become AT square. So just add this. So you will get the final equation. Displacement covered is S is equal to UT plus half AT square, and this is known as second kinematical equation. See, we are studying kinematics. Okay, kinematics is the branch of physics that deals with the motion of an object. Okay, kinematics is the branch of physics that deals with the motion of an object. So this is the second equation of motion, na? So we called it as second kinematical equation. Okay, got my point? Now coming to the third one. For the last, what you have to do is, this is the third kinematical equation or third equation of motion. If we say V square is equal to U square plus 2AS, right? So now we'll again find out the area, because we don't need time here. We'll again find out the area, only the method will be different. Now we will take this trapezium. Initially we broke down this trapezium into two parts. One was the rectangle, other was the triangle, right? But now we'll be finding out the area of trapezium. Okay, so what is the area of trapezium? Half sum of parallel sides into height. Half sum of parallel sides into height. So sum of parallel sides, now take a very close look. This OD, side OD and this EB are the parallel sides of the trapeziums. This OD and EB are the parallel sides of the trapezium, right? And this is the height of the trapezium. This AD is the height of the trapezium. Okay, or you can also say OE, it's the same thing. So OE, or this is written A, na? So AD or OE, it can be any of it. So both are the height of the trapezium. So at the place of height we take time. Okay, so OD is one parallel side, I mean the one side, BE is the other parallel side. Okay, so in place of OD, just take a look. In place of OD we'll write U. In the place of OD we'll write U. In the place of BE we'll write V. In the place of OE we'll write T. So just take a look. This will be the equation. S is equal to half V plus U times T. V plus U times T. Now what we have to do is that we have to see, in third equation of motion there is no time, right? Then what we have to do is we have to change this variable into some reasonable variable, so that we can remove this time. So what we will do here is, take a look. Now acceleration is equal to V minus U by T. So in the place of T, what we can write is V minus U by A. T is equal to V minus U by A. See, take a look. T is equal to V minus U by A. So in the place of T, V minus U by A, now just put the value of T V minus U by A. then you will get half v plus u into v minus u. This is the equation, this is the value of time. Okay, we simply found out the area of the trapezium, which is sum of parallel sides into height. We just wrote it down that okay, OD, in the place of OD it was u, in the place of B it was v, and in the place of OE it was t, right? So when we wrote down the area of the trapezium, half v plus u into t, so because in the third equation of motion there is no time, so we need to change this variable into some useful variable. So what did we wrote? A is equal to v minus u by t, right? We bring t here, so t comes out to be v minus u by a. We just put it, see, this is a plus b, a minus b. Getting my point? So what is a plus b, a minus b? A plus b bracket a minus b is equal to a square minus b square. So v plus u, v minus u, it will become v square minus u square, and this 2 will multiplied by a. So s is coming out to be v square minus u square by 2a. V square minus u square by 2a. See, take a look. 2a is sent there with s. So this is the equation that we got. In class 11th, this is the real equation. But in class 9th, we bring u square to this side, and this becomes the equation v square is equal to u square plus v square is equal to u square plus 2as. Okay. But in class 11th, we usually go with this only. V square minus u square is equal to 2as. But it's fine. Both are correct anyways. There is no difference. It's just the frame of reference that we talk about. So v square is equal to u square plus 2as. Are we clear? Now, this was the graphical method. I really want to discuss, before this question, I really want to discuss the, what do we say? The algebraic method. So I'll use some space here in this question itself for the derivation. Okay. Before that, we can start with the numerical. I really wanted to do this. That's why. Okay. So let's discuss about the equation of motion. We call it as algebraic method, and this is very much related to the average speed and velocity, so it becomes very useful sometimes to understand average speed and average velocity. That is why I'm using this. So equation of motion, algebraic method. Then post that we'll be discussing the numericals. Okay. So now we have three equations of motion. V is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. So v is equal to u plus at, s is equal to ut plus half at square, v square is equal to u square plus 2as. This is how we will derive. Now, what is acceleration, bacha? Acceleration is rate of change of velocity. Directly we can say. So rate of change of velocity is v minus u by t. Bring t here. So this is at and v minus u. So you got the first equation very easily. V is equal to u plus at. Okay. What matters is the second and the third equation. Okay. First equation is quite easy. Now what about the second equation? Okay. Now I'll be discussing this with a little less space because this is not very common. Okay. So not this derivation you won't get in every book. So that's why I'll be taking it very slow. Okay. Step by step. So if we want to find out average velocity, now take a look, average velocity. Now for average velocity, normally the formula is total displacement upon total time, okay, or net displacement upon net time, I mean total time. So for average velocity, there is one formula at a particular situation, v plus u by 2. this is the formula for average velocity only when the time interval is same for both the displacements. Okay, so when time is same, then you can write down this formula for the average velocity v plus u by 2. Okay, so average velocity, and this is at a particular case. This formula is not valid for a random case, but at a particular case where the time interval, like suppose we have two displacements S1 and S2. Okay, so in this the object covered S1 displacement with V1 velocity, but time was t only. In second case, it was S2 displacement with V2 velocity, but time interval is again same. So when you will write down the formula, when you will write down the formula, because average velocity is what? Average velocity is total displacement, right? So total displacement here comes out to be S1 plus S2, right? Yes or no? And total time is 2t. Okay, t plus t, 2t. In the place of S1, can I write V1t? Just take a look. V1 is S1 by t. So in place of S1, I'll write V1t. In the place of S1, I'll write V1t. Okay. So in the place of S1, I'll write V1t. Plus in the place of S2, similarly I'll write V2t upon 2t. Take a look, here the time will get cancelled. So what is the final formula that you are getting? V1 plus V2 by 2. So this is, if V1 is taken initial velocity, so in the place of V1 I can write U. So V plus U by 2. So this V plus U by 2 is at a particular case. Remember, it is at a particular case where sure beta, Karthik, definitely like this week we'll be surely done with this chapter. So from the next week we'll be definitely starting with force and laws of motion. Okay, so this is like the last part that we are covering. Post that, anyways, I'll be completing force and laws of motion, so don't worry. This is the week where we'll be discussing motion. We'll be continuing the discussion of motion, but post that, I assure you that we'll be discussing force and laws of motion. Okay. There's a net problem at my end. You cannot see. Is the video blur? Okay, fine. So everything seems fine. So V plus U by 2, remember this is at a particular case when the time interval is same. Okay, so when the time interval is same, that case only you can write the formula for average velocity V plus U by 2. Okay, now, but because I have to find out the second equation of motion, so I am using this. Okay, so take a look now. So what I have to do is, this is where I'll start again. So V plus U by 2 is equal to average velocity. Now simply multiply both sides with time. Okay, so when you multiply both sides with time, here you are getting V plus U by 2 into time. Okay, and this is average velocity into time. So average velocity into time, this is basically velocity into time, no? Velocity into time. Okay, no worries, sure. Yes, okay. So average velocity into time is displacement. So V plus U by 2 into T is displacement, right? Now, In the second equation of motion, s is equal to ut plus half at square, we need acceleration as well, right? So I'll use the first equation of motion. In the place of v, because in second equation of motion is s is equal to ut plus half at square. So in second equation of motion there is no v, no? So in the place of v, can I write u plus at? Okay, I'll write u plus at. So in the place of v, I'll write u plus at in the place of v, plus u divided by 2 multiplied by time. Now simply what you have to do is just add u into u, it will become 2u. 2u plus at multiplied by t, it will become 2ut plus at square by 2 is equal to displacement. Got my point? Right, I'm keeping the pace very slow just to make sure that you guys are understanding, because this is not very common and this is not covered normally in the schools. Okay, they just give you the equations of motion, they give you the derivations from the graphical method, not this method. So I personally like to teach this method just because it is not very common and you should know it. Okay, so 2ut, just bifurcate 2, so this becomes 2ut by 2 plus at square by 2 is equal to s. Cancel this 2 and then you will get the formula s is equal to ut plus half at square. This is how we do with the algebraic method. Okay, this is how the algebraic method is. So first equation of motion we understood it clearly, v is equal to u plus at. Second equation of motion, you have to remember that it should start with the average velocity. So for second equation of motion, your average velocity concept should be very clear. Okay, this v plus u by 2 is not for every case, it is for a particular case in which the time interval is same. Okay, got my point? In which the time interval is same. So when the time interval is same, then only you can apply this formula v plus u by 2, otherwise it is not valid. Okay, then you have to go for the total displacement upon total time. That is the only formula which is valid for any case. Got my point? Then you multiply it by t, average velocity into time is displacement. Here in the place of v, I wrote u plus at, then I added u with u, so it becomes 2u multiplied by time, so it becomes 2ut, and at is also multiplied with time, so it becomes at square. Bifurcate the 2 and you will get the final answer. So the final equation of motion is s is equal to ut plus half at square. Okay, got my point? Yes or no? Right. So let's get to the last equation of motion. So I'm erasing this one. The first equation of motion, I hope that you guys have copied down, and anyways you can re-watch it if you want to note it down. Now coming to the third equation of motion, again starting with the same concept. The only difference that it will bring, that in the second equation of motion we changed the variable v. Now for third equation of motion we don't need time. So what we will do, the third equation of motion is v square is equal to u square plus 2as, right? So anyways the method will be same. The only difference in the third equation of motion will be that it won't have any time. So right, what was the formula for average velocity? Not the general one, the exceptional one. So the exceptional one was v plus u by 2, right? And I told you that this formula is only valid when the time interval for both the displacement is same. So this is the exceptional formula, just like in chemistry. In chemistry we get most of the things exceptionally. Like there are more exceptions than more theory, which I personally don't like, to be very honest. I don't know how our chemistry teacher Priyanka ma'am is able to teach you so well, because for me chemistry is not the thing. I cannot be exceptional, but Priyanka ma'am definitely is. So let's continue. V plus u by 2 into t, average velocity, again multiplied by time. Right, so here we got the displacement, right? Displacement we got. But the only problem now in this equation is that we have to remove time. We have to change time into some new variable. So let's use this. See, if you remember, the very basic formula for acceleration, that is v minus u by t is equal to a, right? Equal to a. So in the place of t, what you can write is v minus u by a is equal to t. So in the place of t here, use v minus u by a. Okay. So v plus u by 2, in the place of t, we can say v minus u by a. Okay. So average velocity into time is anyways displacement. Again, use the mathematics, v plus u, v minus u, it will be v square minus u square, right, upon 2a. So v square minus u square upon 2a is equal to s. Now finally we got the third equation of motion, v square minus u square is equal to 2as, or v square is equal to u square plus 2as. Got my point? So this is how we derive the three equations of motion by the algebraic method. Okay, this is the exact way to derive the equations of motion algebraic method. So in today's lecture, just remember that we discuss about the velocity time graph, we discuss about the slope of the velocity time graph will give you the acceleration. The area covered under velocity time graph will give you displacement, right? We also gave you the extra edge that, if we have the acceleration time graph, then the area covered under acceleration time graph will give you change in velocity, not the velocity. Then we derived the equations of motion graphically, which you can definitely practice. And also, I would suggest that if you really want to understand these equations of motion, do derive these equations of motion by the algebraic method. Okay, so I will keep till here only. That's it for today, because in the next class I'll be only discussing the numericals related to these equations of motion, and also I'll be discussing this very small part of uniform circular motion. So the next lecture will be the last lecture of motion, and also it is very important because we'll be discussing about the uniform circular motion. Uniform circular motion comes in a very deep manner when we go to the class 11th, right? So I really want you people to understand uniform circular motion in a very brief manner. So do attend the next class. Till then, bye bye, take care, enjoy yourself.